Welcome again to Consult. Today we'll be looking at highest common factors. Highest common factors, HCF. You can see we are taking it gradually. If your topics are following each other, so I don't want to jump from one topic to another. So I want to be able to finish this. Our whole numbers, multiples, prime numbers, and the rest like that. Previous class, we talk of common multiples, and we talk of common factors. So we're looking at highest common factors. Okay, today, example, find the highest common factors of the following: 45 and 30, 25 and 75. So I'm going to do A, you do B on your own leisure time. Yeah, do B on your leisure time. Okay, I'm using two methods for you. Pick any one you like. You understand now? Method 1, list the factors of each. List the factors of each. 45 factors of 45, we have 1, 3, 5, 9, 15, and 45. Factors 30, we have 1, 2, 3, 5, 6, 10, 15, and 30. So where did they have common factor? They have it at 1, that is why you see me circled it. They have it at 3. They have the same at 5. They have the same at 15. See, that is their common factors. 1, 3, 5, 15. So which one is the highest factors among those factors? You have the HCF, highest common factor of 30 and 45 give you what? 15, because 15 is the highest common factor. You can see between both of them. So the second method, you go through this, you draw your table, 45, 30. So you use your prime numbers to divide. You have your prime number, that is 2, 3, 5, 7, and so on, prime numbers. So you use them in dividing these numbers. So 45, 30, start from your first prime number. 2, can 2 divide it? Yes, 2 can divide. So you have 2, 45. 2 can divide 45, you repeat your 45. 2 in 30, you have 15. Can 2 divide any of the two numbers again? No. So you go to which number? Can the next number, 3. 3 can divide. 3 in 45, you have 15. 3 in 15, you have 5. So can 3 still divide 15? Yes, 3 can still divide. You go to 3. 3 in 15, you have 5. 3 in 5 is impossible, you have 5. 5 in 5, 1. 5 in 5, 1. So you will observe that the one circled divide the two identities, the two parameters given, that is 45 and 15. So the number that divide the two, or maybe it's 2 things they give you, or 3 things, the one that divide the two gives you one of the factor. Then second, we can see that 5 divide them, the 2 also. 5 here, 1, 5 here, 1. So you circle the 2, you circle the 3, you circle 5. Then your HCF, when you multiply together, give you what? Your 15. 15. So let's see another more example. See another example. Okay, now I'll quickly go to lowest common. So I'm going to now do one combined lowest common multiple. That is your LCM. Okay, lowest common multiple. So let's make use of this also. You can make use of this. You can make use of this. Of the following. Okay. A, don't forget let's use the table method there. You can use your multiple method also. So anyone you can feel like. Let me give it to you then. Method 1. For your own, well, I prefer you use the table method here. this particular one because the figures are big. You're getting that? Method 1, you list the multiple of each, right? Of each. When you list the multiples, so you multiply of 45, you have 45. You have 90, 105, 105, 150, and so on. 150, 135, sorry, 135, 180. Okay, so your 30, 60, 90, 120, 150. Okay. Then if you look at it now, lowest common multiple is what you want to find. Where did they have the same? Where did they have the same number? The LCM of 45 and 30 now give you what? Where did they have the? So that is 90. Get that? That is where they have that. That your lowest common factor is the first multiples of the two of them. The first common multiple of the two of them. Your lowest multiple. The first common multiple of two of them. We did common multiple. So that should be easy. So you go to the table 2, the table 1, method 2, method 2. So whichever one you like, you prefer. 45, 30. Say you make use of your what? You make use of your prime numbers to divide. 2, 45, 15. 2 can divide again. 3, 15, 5. 3 can still divide. 3, 5, 5, 5, 1, 1. Okay, so your LCM now is the product of the factors. Get that? 2 times 3 times 3 times 5, and I give you 2 times 9 times 5, and I give you 90. Whichever one you have, you want to make use of, either this or this. You get that now? Okay. Let's see this question now. Okay. Find the LCM and the of the following. I have to find the LCM, so I'm going to make use of table on this one. So of the following: A, 30, 50, and 90. B, 120, 60, then 45. Okay. So I'm going to make use of. I'm going to do A. You try the second one. Solution. Or let me make it C. So I'll make use of table. I will do 2. 115, 78. Okay, now let me use 70, 45. Okay, so we're looking for what? LCM and ACF. So solution, you make using what? Table. I'm using table method. A, 30, 50, 90. Don't forget, when you are dividing, it gives you, like I said the other time, make use of your prime number. So 2 can divide them, yes. 25, 45. Can 2 divide again? No. So what can divide them? We have 3. 3 have 5. 3 can divide this one. You repeat it. This gives you 15 also. 3 can divide again. The next thing you have 1, 5. Okay, yes, 3 can still divide this. You make sure that you exhaust the number. You have 5, 25, 5. Okay, so 3, 5 now. 5 now, 1, 5, 1, 5, 1, 1, 1. Now, don't forget, while you are doing it, the equation says LCM and HCF. So the one that divides the 3 of them, that one is one of your factors of your HCF number. Okay, because 2 divide the 3 of them. The 3 divide everything here? No. The 3 divide everything here? No. The 5 divide, yes. Yeah. Good. Divide everything here? No. So therefore, HCF of 30, 50, and 90 equals what? 2 times what? 5. I give you 10. That is the highest common factor they have. Highest common factor between the 3 of them. Are you getting that? Okay. What of the LCM? Your LCM is a multiple of everything here. Lowest common multiple between them, where they will have common multiples when you are finding their multiples of number. So that gives 2 times 3 times 3 times 5 times 5. Okay, so that gives you 6 times okay, 2 times 9, that is 18 times 25. Okay, so your 18 times 25 will give you what? We'll be doing that some other time, so you know how to multiply two numbers. 18 times 25. We'll treat more of this later. 40, 9, 6, 3, 5, 4, 0. That give you what? 450. You see that? We'll treat that later. I'll give you what? 450. 450. So the lowest common multiple between 3 of them would be at 50. Okay? B. You have 120, 120, 60, 45. Yeah, that. So making use of my 2, I have 60, I have 30, I have 45. So it didn't divide the 3 of their own circle it. Okay? I have 2 again, 30, 15, 45. It didn't divide the 3 of that 2 again, 15, 15, 45. It didn't divide the 3 of them, I won't circle it. I have 3, 5, 5, 15. This one divide the 3 of them. This particular 3 divide the 3 of them. So I have that. Then I have 5. Okay, 3 can still divide because there is 15. You have 3, 5, 5, 5. It didn't divide 3 of them. So I have 5, 1, 1, 1. So it divides the 3 of them. So my HCF now of 120, 60, and 45 equals 5. That is 15. While my LCM equals what? You multiply the 3 of them. That is 2 times 2 times 2 times 3 times 3 times 5. You see everything. So this is 8 times 9 times 5. You get that now? And I give you That is 8 times 9 is 72. 72 times 5. 5 times 2, 10. 5 times 7, 35. Plus 1, 36. I give 360. So that is how we treat this one. Somehow they ask you what is the product of the LCM and the HCF. LCM and HCF of those given values. That is 10 times this, 15 times this, product of them. I get it. So we are not asked, but if you are asked, that is how you will solve it. Okay? So come to the end of today's class. To get the next class, subscribe and click your notification button to get the next video of next class. See you next class by God's grace.